Hello, my name is Nicolas Giliberti-Taroco. My partner is Tristan Samson, and this is project three of our Fluent project. So for this first video, I'm going to do the Inviscid flow. I'm going to be showing the geometry and meshing. For all three cases, they're going to be the exact same, my geometry and my mesh. So only in this video I'm going to include it because it would be kind of redundant having it in all three videos. But then I'll always show my setups and show my results for my streamline functions in all three things. But first, I'm going to start by creating a new Fluent project and going straight into geometry. And once that opens, I'll get back to the video. As mentioned previously, but I'm going to be working with a 2D plane. I just put that in the properties before I open the design modeler. So here I'm going to click my Z axis and I'm going to start my sketch. My first step is going to be drawing a circle from the origin right here. Doesn't matter how long it is currently. Then I'm gonna go to dimensions. I'm gonna make my radius of the circle gonna be 0.5 meters, 0.5 meters, and then I'm gonna go back to sketch, draw over here. I'm gonna draw a rectangle around the circle. Then I'm gonna go back to dimensions, horizontal dimension, here, here, here. I'm gonna make it 50 meters, and I'm gonna make my vertical length as well 50 meters. And this is gonna make our inlet. It's like a field for our inlet and out. I'm also going to make our length distance from the center over here. Simple. 25 meters. And I'm also gonna make from 25 so I can be right in the middle. Zoom out. We have our square around it. Our in the center we have circle. Then I'm gonna generate a sketch. And then over here, I believe. Run all these things. For my sketch. What else? And my units are also meters, concept, surfaces from sketch. I'm gonna click my sketch one. File. Um, apply materials, generate. There's my generated sketch with my cylinder in the from that my mesh. I'm gonna update, make sure everything got transferred. Waiting, waiting, waiting. When it says open, my first step is going to be inserting my method. I'm going to select this as my face and apply over here, and then I'm going to click method and I'm going to choose triangles. And then this will be good. We have the triangle method, question, bring through here, and now generate. Now we have the triangles here. We have our cylinder. If we want to make it better, now we can insert sizing, sizing over here, and we put this edge over here. And we apply the geometry. We're going to change this to number of divisions and choose 200 divisions. And various and then it goes just to hard. And then we should generate mesh. We have edge sizing now. Load should find holding around the cylinder, which is what's going to be most important for us. Recording it. And then we're going to insert, we're going to go down to inflation. So we're going to select our face, and then we're going to select our boundary right here. See, edge some phi, and we're going to do first layer thickness, and then we're going to choose our 3 0.000. And we're going to use 100 layers. The more we do, the more better our results are going to be for my computer to run. Mesh. Mesh. We have our black. We're also going to do one more thing. A few more things over here. I'm going to change our element sizes. Here's meshing. I'll get back to the recording when it's done meshing. Here's our mesh. A few more things we got to do. I'm going to select edge select over here, and I'm going to start naming our thing. So I'm going to name up here and here our symmetry. Where's create name selection? This is going to be my symmetry. Over here is going to be my this is going to be my pressure outlet. Here, I need to put velocity inlet. That should be all good for the mesh. Now I'm going to move on to the center, which I'm just going to show what I did for Inviscid in the Inviscid setup that I have. 2D double precision as usual. And while that loads up, it should not take. I'm going to be closing these. Force this so my laptop doesn't cry. Almost there. Everything I edited for the Inviscid flow. The other videos I'll be jumping straight into setup since my geometry and mesh are the exact same thing for each single scenario. The only thing that's different is my set. Come on, laptop. Well, there's a beautiful mesh. I think it. Same steps I did right now, previously. First things first, I'm gonna go to general. Well, first I'm gonna check that this is pressure-based, steady, planar, and absolute. I'm gonna go over to model. Well, we'll go to general first. What's Hmm, interesting. Where, let's just keep it. First things first, I go to viscous and I select Inviscid. For this scenario, it's going to be Inviscid. Go to my materials there. It just shows up one as my density. For this case, I'm going to check over here. My stall zone conditions should all be good. Air boundary condition, boundary conditions. So I'm going to change my inlet velocity to 5 meters per second, as it said in instructions, 5 meters per second over here. Here, make sure my wall and everything is good. Should not penetration. Yep, buffer outlet. Just nothing. When I go to my reference values, and check velocity inlet and make sure that everything here is exactly what I. So something new that we're starting to do. So I created a new report definition. What I will do is click new, force report, drag, and then I'd click whichever one for drag coefficient and for drag force. The first one I believe is drag coefficient. You can see once we initialize and start it. So now we're gonna initialize. Made 25 iterations over here. One part. We'll get back to using. For Inviscid flow, I changed this from coupled to simple and from second order to custom. And now I'm going to initialize my 25 runs. On track, perfect. And now I'm going to run my calculations. I'm going to run 1,000 iterations. Should take a second. This is going to be my drag. One of these is drag and one of these is drag force, drag coefficient. And here are my velocities. Once the calculations are done, we can go to our report definitions. And if we click compute, we have to select wall. This is going to be our drag force. This is going to be our drag force for Inviscid flow. And if I go to this one, the coefficient compute. And this is going to be my drag coefficient. It should be near zero. Obviously, we're not going to get exactly zero, but this is close to zero as we can get using our Inviscid flow. I'm going to go to plot. Well, actually, graphics, contours. I made two contours, one for my the static pressure, and it's going to include all of these. Once I display it, here we're going to see our static pressure distribution for Inviscid flow. You can see we have high pressure here and here, which represent when we would have low velocities at these points, and then higher velocities up here, which would make sense when compared to our other contour for velocity. You see the exact opposite. High velocities and low velocities. Where the pressure is high, the velocity is low. We're going to go now to our plot diagrams. So I've plotted the pressure coefficient throughout the whole thing. So this is our pressure coefficient. It starts at 1. At the position 0, it reaches -3, and then at position 0.5, it reaches to 1. We can also show the curved version of this, like this. And we also have our velocity magnitude on the wall. And it's not 0 because it's not a no slip condition, because it's inviscid. We can also show our forces. At this should be our drag, I believe. If I print that coefficient right there. And if I do the opposite, close forces, if I do 0 to 1, it should be our lift coefficient, which is very close to 0. It gave me a negative, but it could be negative. So, yeah, it's also here. Come back, I'm going to be opening my ropes now. Mistakes, all good. Results section. And the only thing I did in the results section was create a streamline for my Inviscid flow. Let's make parentheses. Yeah. Then our streamlines representing our velocity. This should be all for my Inviscid flow video. I'm gonna start my other video picked up at our setup for my laminar flow.